right, hey everyone. So we're going to be looking at another Leetcode problem today. And the problem is 1855, maximum distance between a pair of values. So yeah, let me just go through the question, maybe explain it, then we'll go to the brute force and the optimal approach. So yeah, this question states that we're given two non-increasing zero-index integer arrays, nums1 and nums2. And what we're basically trying to do is we want to find the maximum distance between two index values, one I from nums1 and j from nums2, such that j is greater than or equal to I, and also the number from the second array has to be greater than nums1. So yeah, and if there's nothing like that, then we have to return 0. So yeah, I'm just gonna explain this over here. What this is basically trying to say is, so I can start from this index over here. Let's say I start from index 0. So this is my I pointer. And I need to find an index from j such that it's greater than or equal to I. So basically I could start from 0 and go forward. And the value that corresponds to that index has to be greater than or equal to the number from nums1. So let's just kind of do a dry run over here. So if I look at 55 and let's say I'm considering 100. Yes, so 100 is greater than or equal to 55. So we have the index values over here as 0, 0, which corresponds to 100 and, it corresponds to the number 55 and 100. And this is valid because 100 is greater. So I can keep my answer as j minus I, which is going to be basically 0 over here. So after that, let's go to the next value. So we have 30 here at index 1. So again, we have to start from an index greater than or equal to the current one. So again, we're going to start our j from here. Okay, so as we can clearly see, there is nothing from that index 1 in nums of 2 that's greater than 30. So yep, that's not going to work. So maybe let's go to 5 over here. So if we take 5 from index 2 over here, we see that, yes, 10 is greater than or equal to 5. Okay, that's a valid answer. So let's try to expand from there. Let's see. Okay, we're going to go to the next value here, which is, which is another 10. Again, it's greater than or equal to 5. So let's go further ahead. We have 5, which is greater than or equal to 5. So if we look at the index value over here, this is 4, and our starting index was 2. So we get for the index values of 2 and 4, we're having all these values here. Again, it's going to end up being 5 and 5, that element there. And eventually that does work. So our answer is going to get updated again. And now it's going to be 4 minus 2, which is going to be equal to 2. So if we consider this for the whole array, that is the optimal, that is the final answer. So the maximum distance that we can get according to these conditions of what is valid is 2. So as you can see, this is basically the brute force approach that can be done. So I've just written the code over here. As you can see, we're doing the same thing. Yeah, we have these two sizes initialized here. We're going to take an answer, initialize it to minus infinity, so we can maximize from there. We're iterating through I, each number in I, and we're going to start j, and j is going to be starting from I to the length of the second array. Okay, this may be our answer. I don't know, maybe not the right convention to name it, but okay, and every time if that number is greater than or equal to the number from the first array, I'm considering this maybe answer, and then I will update my answer based on that. So there is a possibility that after doing everything, answer might still be equal to float minus infinity. So in that case, as they've asked us, we want to return a 0. Yeah, or else we're going to return the answer. So this is the brute force, and as you can see, it's not very efficient because we're doing 2 iterations over here. So that's going to be a time complexity of, I've written n square, but it's actually n into m, and then we don't have any additional space, so that's O of 1. But this is the brute force approach, and obviously we want to optimize from here. So the question is how. And if you look at the question, the major hint that's given here is in this first line itself. So when you say we have two non-increasing zero indexed integer arrays, we're basically saying that they are decreasing. And what does it mean for an array to be decreasing? It means it's sorted in reverse order. And if it's sorted, then off the top of our head, we can tell that things that can be used on it are probably binary search and two-pointer approach. Maybe they can be. And fortunately, in this case, both of those are valid solutions. And actually, it's pretty weird because binary search is normally a very optimal approach, but here it's not the most optimal approach. The two-pointer approach is, but we're going to discuss both. And I think first, let me go ahead and kind of explain the binary search approach, and then we'll just check the two-pointer approach. Okay, so as we saw from these arrays over here, what we were doing is we were searching from, okay, for the first array, we were taking an index. And then from the second array, we were going to take another index, which starts first from the same value of I. So j would be equal to I. So if for every index, I'm taking, for every index, I'm taking a value and then I'm searching from that index forward, like all of this. And I know that they're in a decreasing order, then I can definitely use binary search to my advantage over here and basically do it. It would be the same thing, but reversed, because I know it's decreasing. So instead of iterating through all these values over here, I can actually, I can make it in log m time over here. So that's a basic intuition. So I'm still gonna iterate through each value here, but from that index onwards over here, I'm just gonna split it in half and utilize my sorted nature. So what would happen for the time for this would be O of n into log m. That's for the second array. So yeah, why don't we go ahead and I could just switch to my keyboard and code this up. Let's see. Okay, I'm just gonna kind of comment this out. Okay, so what do we need? Again, we need our answer. First, I'm gonna initialize m and n over here. nums1, nums2, okay. And then what I do need is I need an answer. So this can probably, I'm just going to keep it to 0. That's what we want to return eventually. So the first thing we were doing is we are iterating. We're iterating through the first array, right? So I want to do for I in range m. And every time I do that, I'm gonna start a binary search in nums2. So again, I want to have an L and an R, which I'm going to be initializing to I itself and the maximum length of the second array, so n minus 1. And we're going to get like some value over here. Let's consider it best j value. So best j value by the rules that were given has to be greater than I. So let's go ahead and put a default value of I minus 1. You can check that later. So yeah, we just do our binary search from here. All right, so while L is less than or equal to R, I go ahead. Divided by 2. Okay, now I want to check if nums2 of mid is greater than, so if nums2 of mid is actually greater than or equal to nums1 of I. Okay, so if it's greater than, then I want to keep going right because my goal is to kind of maximize the distance between it, right? So I will keep going right. And if I want to do that, then I want to do L is equal to mid plus 1, or else we know that it's less than. So we want to do r is equal to mid minus 1. And we also need to update this. Okay, so if it's greater than or equal to nums 1 of I, then we know that it could be a valid best j value. So best j would be initialized to mid. Okay, so now after doing all of this, there's a possibility that best j was never really updated. So I want to just check that over here. J is greater than or equal to I, then I know that it could be a valid answer. So answer is equal to maximum of answer itself and this best value of j minus whatever I we have over there. Yeah, after we do that, we can go ahead and return our answer. So let's see if this works. Yes, it does work. And the time complexity, as I mentioned for this, is it's m times log n. So can we just write that? Time is m into log n. And then what do we have? Space, nope, we're not using anything. So space is O of 1. Okay, so actually there is a much more optimal approach than this. And this is our two-pointer approach. So we're gonna look at that now. Get back to the iPad. Okay. All right, again, so this works because of the fact that the array is sorted in reverse order. So we'll take this array again, 535, 42, and then we'll take this one. So this is 100, 20, 10, 10, and 5. Okay, so we know that both of the arrays are in decreasing order. So we're gonna use that to our advantage. What I'm gonna start doing is, let me start a pointer I for nums 1 and a pointer j for nums 2. And I'm gonna go ahead and check. See, if I check 55 and the first value here, it's 100. So I can check if 100 is greater than 55, then there is a chance that since my goal is to maximize the distance, there's a chance that I could go further and there could still be a value that's greater than 55. So I'm gonna keep doing that until I go to a value that's less than it. So I wanna maximize the distance between j and I over here. So by the nature of that, yeah, I would go on increasing this to decrease the value in C, basically to maximize j I distance. And once I reach a point where the value is smaller than it, that is when I'm going to actually try to reduce the value from nums 1 so that it can still fall within this category. And that's when I increase my I pointer. So let's just do a dry run over here. So we see 5,500, that works. So I can consider this as an answer. So it's 0 minus 0, that's our maximum here. And now I want to try to minimize this value to increase the distance. I come to 20. Nope, it no longer works. So I'm going to increase my I pointer over here. So now I have 30 and 20. Again, 20 is not greater than it. So if I increase the j pointer, I'm going to go to a smaller number. It's going to be invalid. But if I decrease my left value, I might have a chance here. So I'm going to increase my I pointer again. I come to 5, and obviously this is not valid. So it's going to come to the next value here. And when I check 5 and 10, I see S10 is greater than 5. So that's a valid solution. So we have 2 and 2. This could be our max here. 2 minus 2, that's going to be 0. And now since this is greater than it, I want to try to decrease this and see how much I can go. Again, 10 minus 5. So this would be 3 minus 2, that's 1. I'm going to go one step further. Yes, that's going to be 4 minus 2 is equal to 2. And at this point, yeah, we can probably end it because we have reached the end of this. And anyhow, none of our values here do correspond to it. So yeah, let me just code this up. I think it would be better to see through the code. Okay. Again, I want an m and an n. Length of nums 1 And nums2 answer is equal to 0. Okay, so what I want to do, while let's just maintain an I and j pointer starting from the beginning, while I is less than m and j is less than n. So what was I doing? If nums2 of j is greater than or equal to nums1 of I, then this might be an answer. So answer is equal to max of itself, j minus I. And if it is, I want to further increase j to see how far we can go. Or else I know that I need to decrease my value to the left. So I'm just gonna go ahead and do that. And surprisingly, that's as simple as it is. And at the end of this, I should be able to return answer, and that should work. And yes, it does. So if you look at the time complexity over here, the maximum that we do is m plus n. So yeah, we have our time over here, which is O of m plus n. We're not taking any additional space, so space is O of 1. So yeah, this is the optimal solution for this problem, and it's actually very, very nice and intuitive. So I hope you guys like this, and yeah, happy coding.